on the global stage. I welcome Prateek and Sri Raj from the Avishkar team to give us a presentation on the new breed of mobility technology.
Hello everyone, I am Prateek Sharma, current Avishkar team head, and I take care of all the technological things. And with me we have Shiraj. He is the business lead of Avishkar. So we'll start with what Hyperloop is. Initially the basic things that we all know about Hyperloop. So we know that Elon Musk brought that idea in somewhat 2013. That he proposed that we can make a fifth mode of transport which is more sustainable and can save a lot of carbon footprint. So, but that idea is not originally from him. This was originally been worked on by Boris Petrovich. So this is the initial idea which he proposed. But at that time he didn't have the technology to make it real. So and we all know it can, if this technology comes up and we put more resources in development and research, it is its potential is to reach up to 100 km per hour of speed, and which can reduce the significant time in the travel. And since it is a ground transport, so the risks are also very less. Then this high speeds we achieve due to reducing the friction. Since we are working on levitation and frictionless propulsion, so using those eliminating friction, we are able to achieve a higher speed on ground. These are our achievements. So for our work, we have been invited by Prime Minister Modi ji when he came to Chennai for inauguration of Vande Bharat train. Then railways also, Railway Minister Shri Ashwini Vaishnav ji also gave us funds in order to set up our 400 meter Asia's first testing set, 400 meter testing facility for Hyperloop. Then we have also got the chance to meet Elon Musk in his first Hyperloop competition, SpaceX competition. So where Avishkar was the only Asian team to come up in global top 10. Then we are currently participating in different competitions. So one of them is European Hyperloop Week. So it commenced in 2021, and we have been the only team there from India, which has been in the top 5 since now. Now, to understand the Hyperloop, I have divided it into different components. So for different we have on-board and off-board. So on-board, all the technical things are levitation, propulsion, electrical and mechanical. So in levitation, we are using levitation model, which we call the electromagnetic suspension. So we have some electromagnetic that ferromagnetic core, and coils around it. And when we pass current around it, it generates electromagnetic. It becomes electromagnetic, and we use different kind of sensors such as gap sensor and current sensor to generate a control loop, using which we control the gap between the track and the levitation module. So this is how we eliminate the friction which in normal transport is generated by wheels and all. So we are eliminating that. And for the propulsion, traction system is there. So currently we are using the linear induction motor. There are different induction motors are there, and reluctance motors are also there. But we have found that using this linear induction motor, energy saving will be very much. So we are using this. And linear induction motor is nothing complicated, just induction motor. And induction motor, you can see there, it's a circular motor. So when we cut it up and expand it, it is a linear induction motor. Then electrical system. This system, electrical system, mainly combining every system together and checking the health of the whole system and checking whether it is working correct, working perfectly or not. Then mechanical system. Mechanical system is basically for having everything. Mechanical system is developing a platform on which we can mount everything: levitation, traction, and electrical system. This is our pod.
infrastructure part. So from Hyperloop perspective, infrastructure is the part which is the most costliest part. Because in order to achieve a 1000 km per hour or 740 km per hour speed, we have to set up an infrastructure which can reduce the track. And for that, we have like vacuum tube. So vacuum tube is the infrastructure, the main component of Hyperloop infrastructure. And it needs to be designed such that it can stand the loads which are exerted by vacuum pressure. And generally, we are introducing that vacuum inside tube such that we can reduce the drag, which is drag forces, which comes on a normal day-to-day transport. Then track, we have track can be customly designed. Track should be able to help levitation and propulsion. So this is a custom track. So here this is this part, F section we call it, supports levitation, and middle T section supports propulsion. And the novel thing about our track and tube is that we have performed some our analysis and test setup and came up with a way such that the load of the track and the pod running on it does not transfer to the tube, and which helped us to reduce the thickness of the tube. So generally infrastructure costs around 84 crores something, and this is part we have divided into 35 crores for track tube, 16 crores for track and all. And after our research, we found we have reduced this number about to 46% reduction we have done. So the tubes which other countries are making for Hyperloop is around 16 mm or 18 mm of thickness. The tube which we have developed is around 6 mm of thickness. So that reduction have reduced the cost, and also the carbon footprint which we get from making steel structure has also been reduced. Yeah, so this is the current facility which is coming up in our IIT Madras Discovery Campus in Thiru, 400 meter of tube. And these are the patent, one patent we have been granted for the evacuation of the tube and the setup of tube and track inside it, such that the load are directly transferred to the pilots. And this one is for our, again for tube systems, for how we, the methodology that we have used to decrease the thickness from 18 to 20 mm, 18 20 mm to 6 mm. Now for the business part, I'll ask Raj to go.
So when we ventured into the pod and the infrastructure development of Hyperloop, we also thought that transportation is not only about developing systems, it's also about how the masses, the democracy, the people are going to perceive. So we conducted a case analysis of to find one thing of how much will it, how costly it's going to be for the people that are going to travel in Hyperloop. So one corridor we chose, that's from Chennai to Bangalore, that's around 350 kilometers, and we found out that the ticket price is going to come around 2,300. So again, this number is based upon various factors that have been already implemented in Hyperloop, if I speak about tech side, and also the various economic factors that have been taken into consideration. So 30 minutes of travel from Chennai to Bangalore, which is 350 kilometers, and it's taking you there with a price of 2,370 rupees. So if I speak about the current scenario at Chennai to Bangalore, recently Mr. Nitin Gadkari, the Road Transport Minister of India, has proposed an expressway between Chennai and Bangalore that's going to reduce the travel time by to 2.5 hours from the very conventional 7 hours. But Hyperloop can take you there in 30 minutes. And the expressway, the current expressway that I just spoke about, limits you to till 120 km per hour on road. And that is again 740 km here, 740 km per hour here at Hyperloop. And we also considered the railways and airways costs that it would take for an average passenger that's traveling from Chennai and Bangalore. And we are pretty much proud to say that our Hyperloop costs are coming around what that are contemporary about the transportation. So with that being said, I conclude my presentation.
So really proud of our students here. They're doing fantastic work. Thanks a lot.
Thank you, Team Avishkar, for that inspiring way of moving mobility forward. It is indeed a great moment for us to invite Dr. Raghunathan Rangaswamy here amidst with us today. Professor Raghunathan Rangaswamy is currently the Dean of Global Engagement at IIT Madras. His research areas are reinforcement learning, big data process analytics, machine learning, big data. He received his PhD in chemical engineering from Purdue University. He's also the co-director of the Process Control and Optimization Consortium at Nexus Tech University. We welcome you, sir, and thank you once again for making it for the conference. Today is indeed a great moment for us as we witness and we gather here to the signing of the MOU between OMI Foundation and IIT Madras. This MOU signifies a significant step towards a collaboration and mutual commitment to sustainable mobility. I would like to invite Aishwarya Raman from OMI Foundation and Professor Raghunathan Rangaswamy, Dean Global Engagement from IIT Madras, to sign the MOU.